Hey students, welcome to this class. Today we will discuss about combinational circuits. Now we have covered sequence combinational circuits. Today we will try to cover sequential circuit. So just reminding few things that we have covered the last class. These we have covered. Last day we have discussed how to use signal and how to use the structural. We have discussed mux of different type like 4 cross 1, 2 cross 1, 8 cross 1. And then here, basically, we have discussed these. That is a concurrent versus sequential statements. And we have also used how to use process statement. How the signals that are written within the parentheses of process, how they are used. Basically, if in a program you are including process and the signals on which event are taking place, it may be input or maybe some intermediates. If you're not including those signals within the processor, the the program will not simulate. So basically, it is written here like within a sequential statement. We have also covered if uh, if else statement, case statement, loop type, how you will start the if else condition. As you are starting conditional statements, you have to close the conditional statements. How many begin is to be written. It was discussed yesterday. Within the operators of VHDL, we have discussed the logical statement that is AND or AND, NOR, XOR, XNOR. You must go through these programs, how to program these logical gates that must be known to you. These are some relational statements that are used within the program. It will be covered also. Some arithmetic shifts like plus, minus, asterisk, slash. Is it giving a remainder? Is it giving quotient like that? Some rotational programming is also done like SLL, shift left logic. It is shift left logic. You can also correlate this with a register. Similarly, SRL, ROR, ROL, and then is the fourth concatenation. Basically, this operation is used to join the bits of different size. Suppose A is a array of size 4 and B is a array of size 5, and suppose C is just a single bit, then you can uh, you can join you can join A and C to have a size of 5. For adding them, basically for adding them, you will use AND operator to get a 5 bit. The size, if there is a concern of size, if there is error due to the size of the array, there you can use this concatenation operator. And just starting with the sequencer circuit, let us form the D flip-flop, how you will code for D flip-flop. So starting with this, let us start the model sim. See, model sim, this is used for coding purpose only. For implementation purpose, I will show you maybe today Jalings portion, how you will implement the circuit on Jalings. how you will implement circuit on Xilinx. You can download this software for programming purpose. It is freely available. If you will search it on Google or get to my PC, you will get the everything. So just adding key flip-flop here. PF key flip-flop. Very IEEE use IEEE dot std dot 1160 dot all p p underscore ff is. You must know D flip-flop. Uh, if D flip-flop is concerned, D flip-flop is basically D flip-flop is a circuit that is accepting the input and is giving the same output, but it is a sequential circuit. So if its excitation function is concerned, Q is less than equal to D. If clock is okay, and if it is not in reset condition, then it will happen. If it is in reset condition, then it will be always zero. That is, Q will be always zero if reset is high. So while programming, you have to take care about the reset condition also, that what is the status of reset. So taking this D flip-flop, D flip-flop is basically is D flip-flop. It has one input that is D here, and you are getting output that is Q here, and Q is equal to D if RST is 1. If RST is 1, then Q is equal to D. Basically, RST is of low level input, and this is set. If you are going through this deep flip-flop, this circuit, actual circuit is this. There are two AND gate there. They are crossed, connected. It is Q complement. It is Q complement here. And the two gates, these are NOT gates. These are NOT gates. You must be knowing. And they are connected. They are connected using this. There is one NOT, and this is T flip-flop. This is known as actually T flip-flop. So overall, you need to design this circuit. You need to have this circuit. This circuit you need to design. You need to design this circuit. So let us code this. D entity T flip-flop is port. Now at port, if you will view here, at port input is D only. And if you are considering this block diagram, at this block diagram, you can see it has input 1 and one RST. RST you have to take care as input. So just taking D comma RST as in STD underscore logic, then is colon, and then you have to use clock also, since here at the common input you have to use clock. You have to use clock here. You have to use clock at the common input, and that clock may be of phase triggered, label triggered, like that. For that, what you have to do, end entity, and there you have to use CLK also, and let Q is the output. So Q, it is out STD underscore logic. Then is closed. Then is architecture data flow of BFF. See, it is case insensitive. You can write capital D or small d. It is accepted. If flip-flop is, then is begin. Since I'm programming for sequential circuits, so I will use process statement, process, and within process I'm writing and D, RST, and clock. Begin. See, you can see here that if here if here RST means add the circuit that is here, this circuit. If RST is 0, suppose this is 0, then definitely Q will be 0. If RST is 1, then this D flip-flop circuit will respond as per the input. So you have to take care about the structure of D flip-flop also. So before programming, you should know the architecture of the thing which you are coding. You must be knowing that. So let us see. Begin. If RST equals, since there is 1 bit size, RST is of 1 bit size. If RST equals to 1, then Q, that is output, is less than equal to 0. Else, if clock, let's see, try to see how clock is written. Else if clock equal to 1, and clock event, then Q is less than equal to D. Then and if and process and architecture. I hope you have understand this logic. See, initial things are okay. After architecture begin is written. After that process, within the parenthesis of process, you have to include such signals where event will occur. Like without clock, if you will go through this figure, without clock, without clock, this flip-flop will retain its status. This flip-flop will retain its status. On providing clock, it will only work. Even if clock is provided and RST is 0, then irrespective of these inputs, Q will be always 0. So you have to take care of these this architecture. That's why it is written. If RST equals to 1, if RST is equal to, sorry, 0, then Q is less than equal to, or let RST CLR clear, let it be CLR. If clear is equal to 0, then Q is less than equal to 0. Here it is written else if clear is 0, then uh, don't need to do anything. You have to just put Q equals to 0, irrespective of the inputs it is accepting. However, if it is clear is 1, then it will go through other statement. If clear is 1 and a clock is provided there, even if in the circuit you can see here that if there is no clock at the common input, then also the output are retained. That is initial condition of Q is retained if clock is not provided here. That's why it is written here in the program. If clock equal to 1, see, if clock equal to 1 and there is event in the clock, there is clock event, means when clock is at upper age and there is event in the clock, there is event in the clock. Event in the clock means there is change in the clock position. From 1 to 0, it is going. Clock is at one position and there is event on the clock. Clock apostrophe, it is apostrophe and then event. If clock equals to 1 and a clock event, basically it is negative age trigger. Try to understand, this is a negative age trigger. If clock is at 1 and there is event in clock, then you have to write Q equals to D. Q is less than equal to D. Means when clock is accepted, basically through this statement here, using this underscore, you can write comment. Two underscore means after that comment can be written. If clock event, then it means it is negative age triggered. It is clock and if changes occur in clock, then only output will be affected due to input. So this Q is one. Let us compile it. Actually, XOR is selected. Let us compile. It is D flip-flop. There is one error. Let us find this error. There is error at number 10. Then is 15 in end process and architecture. At 15, it is saying end process and architecture. Okay. Labels do not match with data flow. Now see D flip-flop, it is a compiler has been successfully compiling, have compiled this program. So let us see the output. For that, you have to simulate it. On clicking on simulation part, just go and work. There you have to find this file, t underscore ff. T underscore ff is this instant window you have to wait. At instant window, it is visible. Just D flip-flop, you have to add it all waves in the ring. Here, you can see that are three inputs, D, CLR, and RST. D, CLR, and RST. RST is also in here. You must not be RST. So I have to remove RST. RST we are not using. So we should remove RST here. Simulation, you have to end the simulation. Since RST will be useless here since it is not included in event portion also. Let us see what is affected. Since RST is not, try to see in the program, here RST is not included. If suppose RST is, there are changes in RST, is it affecting the output? You can see here, suppose D is 1. Let us take it as, let us take it as 1 at first. Let it be in the clock type, PS. This clock. CLR, suppose it is 0. Clear is 0. Then definitely Q will be 0. RST I'm also forcing to 0. Or I'm not using RST. Let us see. Let clock is, since it is clock, you have to give input as a clock type. So 100 PS, it is nanosecond. So nanosecond here. You can change this nanosecond to T. We have to take it as 16 nanosecond. Now let us see the out. See, I have not taken RST. I have uninitialized RST. RST is uninitialized. Even this is not this has not been used in a program. So either remove this part or you have to end the simulation. Then you have to again compile it and then simulate it. It will be removed. Just for removing any of the content here, just select that and delete it. It will be removed. Now try to see here, since CLR is 0, clear is 0, and clock is applied. And clock is applied. See, even on applying clock, it is not RST since clear is 0, clock is ineffective. Clock is ineffective here, and Q is always 0, irrespective of the inputs that is changed. Now, let us clear is 1. It is 1. Then see, is it affecting the output or not? Error here. Again, showing error. Why there is error? Clicking on this key flip flop. Add on with all items in the region. So D, let us take it as a clock. In a second. CLR, I have to keep it. Let it be 1. Let it be 0. See its effect. Clock is of clock type 100 PS. Then see down. See, clear is 0 and clock is available. Even then output is 0. Even then output is 0. Now suppose clear is 1. Suppose clear is 1. Then see else statement is working or not. Now for the zero input, output is changing. Suppose input is of clock type, it be 100 ns. See here, clock is applied. You can see when D is 1, Q is 1. When D is 0, Q is 0. Clock is changing. When input is changing, then only output is changing. Q is equal to D. It is happening when clear is 1. When clear is 0, then irrespective of the input, output is always 0. When clear is 0, you can see that till this is output is 0. When clear is 1, then Q is affected by the input. Just reducing this frequency, that frequency is 50 nanosecond. Now try to see the changes here. See the changes. See, at decision is taken being taken at the this positive is D is 1, and so output is 1. It is retained till the next pulse. Even here D is 1, so output is retained, and so output is always 1. Now let us change the frequency here. Let us make it 100. Let it be 150. 150 PS, then see the out. So this is all about D flip flop. Now let us start with JK flip flop. How it is working here? How you will code for it? Adding to project JK underscore FF. It here. And then JK flip-flop is here. Paste it here. It is JK, JK. Here it is JK, JK flip-flop. Input is J, comma K. CLR clock is okay. Q is output fine. It will be J and K here. J, comma K. CLR split is 0, then Q is 0. Fine. If clock is equal to 1 and a clock event, then you have to write here conditions. Here we will use two statement, then two if statement. If J equals 0, J equals 0 and K equals 0 and K equals 0, or you can use case statement also, like J and K. Let us, it's better to use J and K here. Case K is when 0, 0, then Q is less than equal to Q itself. Q is less than equal to Q means there is no change in the output. Output is retained. No change condition. Again, when 1, 1 or when 0, 1, then you must know the excitation table here, how it works, or the logical function you may know is equal to 0 when when 1, 0, you have to use it implies Q will be Q less than equal to 0, Q less than equal to 1. Now see here, the three statement you have taken when others, Q is less than equal to not Q. See, within other, you are using a statement like 111 and 011. For 011 condition, that in case of JK flip-flop, when both the inputs are 1, both J and K are 1, and uh, see, it is Q plus in JK flip-flop, it is J q complement plus k complement q. From this here, you can see here that q, j, k, and q plus. When it is here, initial condition is 0 and both j and k are 1, then output is 1. Initially 1 and both are 1, then output is 0. So, considering the same logic here, it is written when others then q. Others means, see, there is only one combination that is remaining here. That is 1 1. When 1 1 is combination is obtained, then q is not q. Q is not q. Then, since you have used one if statement, you have used one case statement. So here, before ending if, you have to end case statement, and then you have to end if statement, since only one if statement was used, and then process statement, and then architecture. Let us simulate, compile this. This thing at number 12. It is saying that q cannot be read as out output, as q is less than equal to q. Here q is acting as input as well as output. So in out. You have to write here in out, since q is acting as in as well as out. There are some other something new we will do while we will simulate it. You have to take care when input when any variable is acting as in as well as out. For that, there are something you have to take care while you are simulating. There is again two error. Let us see that error that is at 12. It is saying that attributability logic extent. Some error in library. Let us take one signal. Signal K std underscore logic, and then I write it here. K is less than equal to K and K. Close. Then write K. It as X. X is J and K. X is J and K. Take X, see the output. Okay, X is of 2 bit. You have to stay logic underscore vector 1 down to 0 will be 1 down to 0. 1 down to 0. Let us see what it is saying now. It's only two error now. Now the two error is this and it is also. Is expecting power slash step number 4. I think there is column here. Okay, dear learners, for today this much. We will continue with the same topic tomorrow. Thank you so much. You may leave now.